this is the homework review for homework 3.3, Scale Factors in Similar Shapes. ACE problems 7 through 18, pages 47 to 49. The first question is question number 7, and it says use the polygons below and list the pairs of similar shapes. In order to find the similar shapes, though, you need to find the dimensions of all of them. So that's the first step you should have taken, is gone through and figured out what all the heights and widths were. So H is 3 by 5. I did the rectangles first, then the triangles, and then the parallelogram. So H is 3 by 5, J is 2 by 9, and P is 6 by 10. And then for triangles, K has a height of 7, a width of 4. Q has a width of 6 and a height of 3, and R has a height of 2 and a width of 4. And then our parallelograms have this one down here, N, has a height of 2 and a width of 4. L has a height of 5 and a width of 6. And then M is tilted, so remember that you have to turn them to that so they are in the same orientation, but it has a width of 6 and a height of 3. So if I was going to figure out what's similar, I would first look at our 3 rectangles. So we have one rectangle, like I said, is 3 by 5, one is 2 by 9, and one is 6 by 10. How can I get from 2 to 3 and 5, or 2 to 3 and 9 to 5? I can't. This rectangle is way wider in proportion. You can tell the height from 2 to 3 would be 1.5. 5 times 1.5 would be more like 7-ish, 7.5. And so that's not going to work. So there's no way that H and J are similar. P is 6 by 10. And looking at H and P, 3 by 5 and 6 by 10, I can easily see that I can double that. If I multiply 3 by 2, I get 6. 5 by 2, I get 10. So it must be H and P. I then look at my triangles, and this triangle is 4 by 7, this triangle is 2 by 4, and again, this triangle's also orientation is flipped. So you're going to want to flip it completely over, but that's 3 by 6. So again, this triangle is way taller in proportion than the other triangles, so it has to be Q and R. If we look at Q, it has a height of 2 and a width of 4. R has a height of 2 and a width of 4. Q has a height of 3 and a width of 6. So to go from here, this is a 1.5. 2 times 1.5 is 3. 4 times 1.5 is 6. That leaves our parallelograms. And this has a height of 2. N has a height of 2, width of 4. L has a height of 5, width of 6. And this one has a height of 3 and a width of 6. So again, looking, one of these parallelograms is not like the other. L is a much more squared shaped parallelogram, where M and N are more similar shaped, and then we can verify it by looking at their dimensions, 2 by 4 and 3 by 6. Now we've talked about how to do a scale factor. Again, 2 to 3 would be 1.5, 4 to 6 would be 1.5. But another way that you can double check it is you look at the ratio, the proportion of the height to the width. In both of these cases, the height is half the width, 2 to 4 and 3 to 6. So that's another way that you can check that they are similar. Looking at the answers, this is what we just wrote, is the similar shapes. The rectangles are H and P, R and Q, M and N. So triangles are R and Q, parallelograms M and N. To go from the smaller shape to the larger shape, H to P is 2. So we said that H to P, 3 times 2 is 6, 5 times 10 is 2, 5 times 2 is 10. R to Q is 3/2 or 3.5. And then M to N is 2/3. I realized I made a mistake. From the smaller shape to the larger shape, it should be from N to M is 3/2. So, sorry, I'm looking right here. Let's just fix that. N to M is 3/2. I'm going to read my own directions. So from the smaller shape to the larger shape, it's still 3/2. There. Okay, so that was that one. That's finding similar shapes by looking at their dimensions, seeing if you can find a scale factor, or seeing if the proportions between the width and the height are the same. For parts A through C, use the grids below for question number 8. Same thing, pretty much with all these problems, if you have a grid, you're going to want to find out dimensions pretty quickly. So our rectangle is a 4 by 3 rectangle. Our triangle is a 5 by 5 triangle. Remember, height we measure from the tallest point to the bottom, which you can measure on the side. So it has a height of 5, and Z is 2 by 6. Sketch a triangle similar to triangle X, but it has an area that's 1/4 the area of triangle X. Now, triangle X's area is going to be 5 times 5 is 25 divided by 2, so 25/2 or 12.5. You can do this an easier way, though, without looking at the area. The fact that they tell you that the area is 1/4 the area. Remember how area relates to scale factor. If I double something, the area is quadrupled. It's 4, it's 2 times 2. If I triple something, the area is 9 times, 3 times 3. The same thing when you're going smaller. If my scale factor is 1/3, then my area is going to be 1/9. So in order to have an area that's 1/4, the scale factor has to be 1/2. And that's what you use here. In order to have an area that's 1/4, the scale factor is 1/2. So if I originally had a 5 by 5 triangle, I now have a 2.5 by 2.5 triangle. And that's how you can figure that one out. Sketch a rectangle similar to a rectangle Y with a perimeter that is half the times of perimeter Y. Again, you could figure out what the perimeter of the Y is and you can cut it in half, or you can recognize that if your perimeter is half as big as the original, then your scale factor is half as big as the original, because perimeter and scale factor are the same. If you double something, your perimeter doubles. If you triple something, your perimeter triples. So if I have something, the perimeter halves. So if my original rectangle is 3 by 4, then my new rectangle is going to be half of that, or 1.5 by 2. And this one tells you the scale factor right off the bat, so sketch a parallelogram that's similar, that has a side lengths that are 1.5 times the side lengths of the original. So this is telling you right off the bat the scale factor is 1.5, so you come back up, it was 2 by 6. So if it's 1.5 bigger, remember to do 1.5, you do 2 times 1 is 2, half of 2 is 1, so your new parallelogram is 3 by 9, because it went from 6. So 2 to 3 and 6 to 9 to get that one. That's how you find one that's 1.5 times bigger. Secret word, I guess it's probably time for a secret word, is Bill Nye. Since in science we watched a Bill Nye video today on respiration, so Bill Nye is our secret word. This is one like we did at the end of class the other day, last time when we did problem 3.3 in class. And you have to use what you have to find out what's missing. So you have 2 triangles that they tell you are similar, and you have to find the missing interior angles, and you have to find the missing sides. The easiest angle to find first is A. That's the one over here in the corner, because remember, angles inside of a triangle add up to 180. They're half of a rectangle, which is 360, so 180 for a triangle. So if you have 64 plus 49, that leaves you 67 for angle A. Angle Q, because these are similar, and you can tell that they're in the same orientation, because remember, if they're similar, you want to make sure they're flopped the same way, and they are. So angle Q exactly lines up with angle B, so Q is 64 degrees. And angle P exactly lines up with angle A, and so it's 67 degrees. And again, you can tell because C and R are both 49 degrees, so they've got them lined up the same way. So now we found the angles. So angles we just found by doing the 180 degrees. Now we need to figure out the sides. And we know corresponding QR is going to correspond with BC here. And 23 to 46 works out well. So we can tell that 23 is half of 46. So in order to go from the smaller to the larger rectangle, you double your side length. It's a scale factor of 2. So length of AB, if we had 19 and we double it, we get 38. Length AC, if we have 22.5 and we double it, we get 45. And to get the perimeter of the larger triangle, ABC, you just add up the 100, add them all up and get 129. You could have also added up the smaller one and doubled it, either way. So there's again their values, 67 degrees, 64 degrees, 67 degrees, 38 inches, 45 inches, and 129 inches. Okay, the last few questions are multiple choice. And same thing, instead of having similar triangles, you now have similar parallelograms. What is the measure of angle D? Well, one thing you need to know about parallelograms, if we haven't talked about it yet, is that opposite angles in parallelograms are congruent, meaning the same. So if A is 55 degrees, then C is 55 degrees. Also, so 55 degrees and 55 degrees equal 110 degrees. A parallelogram has to add up to 360 degrees, so you can take it and you can, so that means B and D have to be 250 degrees. Together, they have to be the same, so you divide it by 2 and you get 125 degrees. The other way to think about it is that A plus D make a straight line and have to add up to 180 degrees. So 55 plus 125 gives you the 180 degrees. So either way, you get the angle D is 125 degrees. What's the measure of angle R? Well, R corresponds with A, so it's going to be 55 degrees. So right there, 55. What's the measure of angle S? S corresponds with Q, is 125 degrees. Oh, look, I'm They made it too hard. They tell you 125 degrees right over here, so you could have just noticed that 125 degrees are the same, because if they're similar, they have the same angles. So that would have been easier. Yeah. So S is 125 degrees because it's across from Q, which means it's the same. And what is the length of side AB in centimeters? We have to figure out the scale figure to figure that out. We're going PQ has a length of 7.5 centimeters. CD has a length of 15 centimeters. So again, to go from the smaller to the larger, we're doubling our scale factors too. And again, I made that even harder because it's a parallelogram. So because DC is 15, then AB is 15. So you could have done it either way. You could have doubled the 7.5 to get the 15 over here, or you could have realized it's a parallelogram, and I already have 15 centimeters, so it has to be 15 centimeters. And I think that's the last question, so thank you for watching. Bye.